Hello everyone, welcome to our Python from Scratch series. So in the last video, we have covered about the lambda functions. Now in this video, we will be covering the most important topic, object-oriented programming, or we call it OOPS as well. So what is object-oriented programming? It is a way to organize our code around some object. Okay, so objects are real world entities. That could be any real world entities that have some data and it has some behavior. And OOPS makes your code act like a real world thing. So you will be able to better understand and you will be able to better code things when you will relate it with any real world entity. So there are four main pillars of object-oriented programming, that is encapsulation, inheritance, abstraction, and polymorphism. Okay, so we'll be discussing about all these in detail. First, let's just understand about the data and what is behavior, what is data of a real world object. So suppose, take an example, we have a car. Okay, so what all data it will have? It has some color, it has a brand, okay, it has some speed, some mileage. Okay, these all are its data. And what will be the behavior? Behavior are basically the methods. Okay, a method of a class, okay, or method of an object that it performs some operation. Like for car, we have some start operation, we have stop operation, and we have some accelerate operation. Okay, so these are some behavior. Basically, these are not static thing like a color or a brand or a speed, which are our data. But behavior is which is performing something. Okay, which is doing something. Like start method will start the car, stop method will stop the car, accelerate will increase the speed of the car. Okay, so these are the behavior of the car. So similarly, when we work with the Python, so we create our classes. Okay, and when we create our classes, we relate it with the real world entity. So in our case, we have taken an car object. Okay, so we'll be creating its similar class. So in this example, you can see I've taken a class car and then I've defined its behavior. Behavior are the methods. So I've defined the start method here. Init is the by default behavior that is provided by any class. So like if you have worked on Java, you have or TypeScript languages, you have seen the constructor. So init is the constructor here. Okay, and then we have other method called start. Okay, and then we will be having other properties inside this method, like we will be having these color, brand, speed, mileage. These are the properties. So you must be wondering what these classes actually are. We have understood that object is something that we have some real world example like car, person, dog, animal, anything. But what is this class? So class is like a blueprint of any real world object. It defines what an object should have. Okay, so if I'm for real world example, if I'll be creating any application, okay, so before creating its class, I have to think it of as an object. Okay, so for example, if I'm creating any a checkout, sorry, the e-cart or e-commerce application, okay, and I want to create the cart class. Okay, so what inside cart class, what I'll be adding? I'll be adding the quantity, okay, the price, okay, and the product ID, product name. Okay, so these things I need inside my cart. So these are the data of the class, and then inside cart I will have the behavior as well, like add to cart, remove from cart. Okay, so these are the behaviors of any class. So in the object oriented programming, the class and objects are exactly the same thing. Object is just the real world entity, and class it's blueprint which I am writing on a paper. Now what is the init, which is the constructor? So what it does? So it is basically the constructor. It's a special method that automatically runs when you create an object of any class. Okay, and it is used to initialize the object's data. So in the last example, I've already shown you. So this is the car class. So what this init method is doing, it's just initializing the object data of car class. As you can see in this example, we are just initializing the object data. That is, this car will have brand, we have color. So when we create any object, we'll pass the brand and color to it, and then it will assign that brand and color to this self.brand, self.color. So basically inside this car, I've set that properties. Now the types of methods. So we have three types of methods that we use: instance method, class method, and then static method. Instance method works on objects data because they are associated with an object, and then class methods works on class variables, and static methods we use majorly to create some helper method. These are independent of any class and object. So let me take you to the Google Colab and let me show you with an example. So I'm inside the Google Colab and you can see I've created one class student. Okay, it has the init method, which is the constructor. Then it has the instance level method. Okay, and we have then class level method, which I have annotated with @class. And then we have static methods. Okay, and now from here we are calling these different type of method. So how we call the static method? We can directly call any static method with the class name directly. Okay, so it is present inside the student class. So I can write the student dot greet and it will call it. Now to call any instance method, we have to first create one instance for it. Okay, so for example, for student, I have to create one object. Okay, and this method will get execute. As I've told you, this is the constructor init method. It will get execute when I create my object. So when I create student object like this, I will have to pass the parameter that I'm using here. So I'm using name here. Self is the default first parameter, and in other languages we denote it with this, but inside Python we denote it with self. Okay, so now I'm passing Amit as the other argument for name, and name will be set to self.name here. Okay, so once this object is created, we have this instance S1. Now with this instance, I can call the instance method inside my class. Okay, so we have this show, and I've called this, and it will print this. Okay, now I'll be calling the class method. So I can call the class method also directly with the class name. So we have student dot change school. This is the class method, and I'll be passing these properties. New school and CLS is the current object. Okay, and what I'm passing here is I'm passing KV. Okay, so new school is passed as KV. So CLS dot school will be set as new school. Okay, so this is the class level variable, and the class level variable school I can access using the CLS property. Okay, so let me execute it, and then I'm calling s1 dot show also again. Okay, the show will again just print the change data. It will show the change data. Okay, now let me execute it. Okay, now as you can see, for the first method, the static method is called, it is directly calling hello student. Okay, so it is directly printing the static method, this one, greet hello student. And the second one is s1 dot show, which is calling the instance method show with the value name. We provided Amit here, which is set to self dot name. Basically inside the object, this value is set. Okay, so Amit will be set with self dot name, and school student dot school. So I'm directly accessing this variable from the class. So by default the value was DPS. So when it's printed, it printed name Amit school DPS. Now when I created a static method, sorry, what is this? Yeah, the class method. Okay, so the class method, what is it is doing, this class method is changing the school. Okay, so what I've done is directly calling the change school and providing the KV value to it. So what it will do, it will change the class level variable. This is the class level variable. Okay, so I provided school KV, and then it changed the school from DPS to KV in the class level school variable. This TPS will be changed. Okay, so when I again printed the instance method show, so what it printed name Amit and school KV. Okay, so this is how we change the class level variable using some class method, and the object level variable can only be initialized one at the time of object creation. So now let's understand the pillars of object oriented programming. So the first one is encapsulation. So what is encapsulation? Encapsulation is hiding the crucial data. So encapsulation is protecting your crucial data from being directly accessed by someone else. And how we do that? We can do that by using the private variables. Okay, so this is how we define our variables. Like if we define it without any underscore directly, so it will be a public variable. If we define it with a single underscore, where it will be a protected variable. And if we want to make it private, we'll use double underscore with our variable. So let me take you to the Google Colab, and I will demonstrate you how we can achieve the encapsulation. So I am inside the Google Colab, and I have taken this bank account example. Okay, so I have this bank account class in which I have this crucial property balance, and I do not want anyone to access this property directly. So for that, what I have done is I have created this as private with double underscore. Okay, and if I remove one underscore, it will be a protected variable. If I remove one more underscore, it will become the public variable that anyone can access and change it. But I have made it with the private variable, and what I have done is I have exposed two method, public method deposit and get balance. Okay, so inside my deposit, I'll add the security checks, that who is depositing the code, who is depositing the amount in this bank balance, has the perfect proper rights or not, who is checking the balance. Inside this get balance method, I will also add the checks. Whosoever is accessing this balance will have the proper rights to this account or not. Okay, so we can add this check inside the methods, but for variable we can't add these checks, so that's why we will have to make it private. And then what I'm doing, I'm creating an object, I'm adding the 1,000 rupees balance to it, and then using the variable account dot deposit method, I'm depositing another 500 to it. Okay, so when I will print account dot get balance, what it will print? It will print 1,500. As first time at the time of object creation, I have deposited 1,000, and then I have deposited 500 more, and then it has 1,500. Now, if I directly try to manipulate the balance on a private property, let's see if it can do it or not. Okay, so what I'm doing is I'm doing account. Let me see if it changes or not. So it didn't change the actual balance. When I'm getting the account.get balance, the balance is still intact. But if I change the variable to a public variable, okay, so I've changed it everywhere. Okay, now let me assign 2,000 to it. See, it manipulated the balance, account balance. You can see here. Okay, so anyone can manipulate this balance if it is public. I can make it even 0. Okay, so that's how we protect our crucial data, by making the variables private. Now, the next concept is abstraction. So, abstraction is showing only the essential information to the end user and hiding the necessary details behind. Okay, so sometimes people get confused with the encapsulation and abstraction. Encapsulation is the protecting your crucial data. Okay, but abstraction is I do not have such crucial thing on the back side, but I do not want to show that that information to the end user, because they, as there is no sense to showing them all the data, because if user wants to just start the car, okay, so I'm just showing them the start car button. Okay, what is the necessity of showing them from inside the car complete engine, how the fuel is moving to the car, how the spark plug is sparking the fuel, and then car is getting started. I do not want to show them the complete engine of the car from the from inside the car. Okay, so what I am showing to them is directly the start button, so they are just concerned about starting the car. Okay, so I've just provided them. So the abstraction is the same thing, showing only the essential features of an object while hiding the unnecessary details. Now, the next thing is inheritance. So inheritance is also called as is a relationship feature. So if the inheritance means we reuse our code, where one class can inherit the properties and method from another class. Okay, so for example, I've shown the animal class. So animal, I'll be taking that as a parent class, and then I'm creating another class dog. So dog is also an animal. Okay, it can inherit the common property from the animal class. So for how I'm doing the inheritance here, so when I created the dog class, I have given the animal as the argument. Okay, animal class. So what that means is I'm inheriting the animal class, and I will be inheriting all the properties and methods of the animal class by default. Okay, so now in animal class I have speak method, and dog class I have bark method. I'm not created speak method inside my dog class, but I'll be able to access it because I'm inheriting the animal properties. Okay, so I've created the dog object, d is equals to dog, and then I'm doing d dot speak and d dot bark, and it will be able to print both. Now I've taken this similar example, same example here, and let me execute it, and I will show you it will be able to access both the method d dot speak and d dot bark. Let me change it to bark. Okay, so the bark method will do the bark, and the speak method will do the speak. Let me change it to just speak, so you will be able to get it. Okay, let me execute it. Both printing speak. Okay, calling the bark. Okay, so now you can see it is accessing d dot speak from the parent easily, and it is also accessing the bark method from its own class. Okay, so that was showing is a relationship. Now we have the composition, which is has a relationship. So composition means one class can contain another class. Okay, when another class is contained by one class, it calls has a relationship. And what is the disadvantage of has a relationship? That when I've defined one class inside another class, okay, it is containing a class, so it has the dependency on that class. If that class fails somehow or not available, some issues in that class, so the outer class will also get failed. Okay, so basically without the inner class object, the outer class which is containing that class will not exist. Okay, but in is a relationship, that there is no such dependency on the other class. We are just inheriting the properties. If the outer class methods are not available, if there is something else is not present in the parent class, but the child class object can be created, and we can execute the child methods. The type of inheritance. We have different type of inheritance in Python. We have single, multi-level, multiple, hierarchical. So what are these? So single inheritance is when I'm inheriting one class. So here B class is extending the A class. Okay, this is the single inheritance. Now the multi-level inheritance. Multi-level inheritance means B is inheriting A class. Now the another class C is inheriting B class. So this is multi-level, one by one. I have created A class, then B class is inheriting the A class, and then I've created another class C which is inheriting the B class. This is multi-level. So all the properties of A will be available inside B, and all the properties of A and B will be available inside C. Now we have the multiple inheritance. So multiple inheritance, that a single class is inheriting from the multiple classes. So for example, class D, I am inheriting the properties of A, B and C. So all the methods of A, B and C, all the properties of A, B and C will be available to class D. This is multiple inheritance. Hierarchical inheritance means that one class is inherited in the multiple classes. Okay, so for example, I have this class A, this is inherited inside B, this is inherited inside C as well, this is inherited inside D as well. Okay, so this is hierarchical inheritance. Now the last concept is polymorphism. And the polymorphism, how we achieve the polymorphism, and what is polymorphism? Polymorphism is one name but multiple forms. Okay, and how we can achieve the polymorphism? We can achieve it using the method overriding. Okay, we can also achieve it using the method overloading as well. And but majorly we use the method overriding concept. Okay, so let me show you how we do it with the method overriding way. Okay, so that is achieved through the inheritance feature, and let me take you to the Google Colab. Okay, so I have one class animal which has one method speak. I have another class dog which is inheriting animal class, and it has also one method called speak, which is which this class is overriding. Why it's overriding? Because in real world scenario, there may be a possibility that code wants to inherit a parent class, but it does not want the methods from that class. Or maybe I want those methods, but I do not want the implementation. The implementation is very old. I want to change that implementation. Like for example, in payment class, in earlier days, we had the limited options for the payment. We can either do it via cash or via the card. But today we have multiple options. We can use UPI, Google Pay, Paytm, and many other payment methods. So we can't stick to that old implementation. So how we can change it? We can change it by using the method overriding feature. Okay, and what I've done is I've just created this same signature, def, same name, same argument. Okay, and what I'm doing is I'm just changing the implementation inside it. So it will directly override it. So now I've created my animal object, I've created my dog object. When I call animal.speak, what it will print? It will print animal sound. But when I will do d.speak, what it will do? Let me execute and see, it will print bark. Okay, so it overrided the method. If I remove the speak method from here, then what will happen? Change speak to talk. Okay, now my child class does not have speak method. I'm not overriding. But when I call d.speak from my dog object, what it will print? It will print the animal sound. It will still point to the old implementation because my dog class is inheriting all the properties from the parent class. So it will still stick to the old implementation. But if I want to change it, I will override it with the same name in my child class. And when I execute it, it will change it to the bark. So that is one name but multiple form. The method name is same but behaving like differently. So that is one name, many form. That is polymorphism. So I hope now you get it. And yep, we pretty much covered most of important concept of the OOPS. So I hope you get it. Now I'll see you in the next video. Bye bye.